Assalamu alaikum students, welcome to your online physics class. We are going to study chapter number 3 which is dynamics 1. In our 9th class syllabus we have two chapters of dynamics 1 and dynamics 2. So first of all we are going to study dynamics 1, in which we will study the basic concepts about the force, about the motion, and about their correlation. So let me recall you a concept we studied in our last chapter, that was kinematics. In kinematics we study the motion of an object without considering its causes. So in previous chapter we basically study when an object is in motion, what are the terms related to its motion, how it is moving, what type of motion it is having. For example, it is having a translatory motion, or having a vibratory motion, or having a rotatory motion whatsoever. And we studied what is its speed, what's its velocity, and what's its acceleration, etc. So now we are going to study what is dynamics. So as you can see in your slide, the study of connection between force and motion is called dynamics. So basically dynamics is the study of cause of motion of any object. So when an object is in motion, or when an object is moving, why is it moving, what are the stimulus behind its motion, what are the causes of its motion, this all study is added into the concept of dynamics. So let's say we have a trolley. If we want to start trolley, then we will have to push or pull that trolley in either direction. Unless and until we apply any force on that trolley, the trolley will not move. So for example, we want to move it forward, so we will push that trolley, and we want to pull it back to make it stop, so we will pull it. So now we are using something that is called force. Pushing or pulling includes force. So we can use this force to speed up that trolley or slow down that trolley, and we can also use that force to change the direction of our trolley. I consider here an object trolley, but you can consider any other example of daily life objects. Every object, whatever it is, needs a force to start, needs a force to stop, needs a force to change its speed, either to speed up or to slow down, and needs a force to change its direction. Without any force, these three factors cannot be induced to any object. So what is force? Force is a vector quantity, and it can change the state of the body. What is state of a body? When an object is at rest, that is its state of body. Our object is moving, that is its state of body. So if we want to change that state, either of rest or motion, we want a force. So that force can cause the change in the state of the body, or can cause the change in the direction of the motion of that body. So there are two types of forces, basically categorized in two types, which are contact forces and non-contact forces. So what are contact forces? Contact, as obvious from the name, means a physical touch. So objects that are in physical contact experience contact forces. For example, when you are playing a football and you are kicking the football with your feet, so you are utilizing contact forces, because until and unless the toe of your feet doesn't comes in contact with the football, you can't exert any force on that football. Similarly, when you are playing cricket, you are exerting a contact force, because until and unless your bat doesn't comes in contact with the ball, you can't exert any force. So there are a lot of other examples. When you are pushing something by hand, you are utilizing a contact force. So there are two examples written here of contact forces. One is normal force. What is normal force? Let's say we have a book placed on a table. So now the cover of the book and the surface of the table are in contact. Now there is a force that is acting on that book in upward direction. Means there is a force that table is exerting on the book in upward direction. So this force is called normal force, and it is always perpendicular to the contacting surface. Next is thrust. What is thrust? In aeroplanes or in jet engines, there is hot gases coming out from the engine, and they exert a thrust on that engine in opposite direction. So that is thrust force, and that is also a contact force. So you can here see there is a normal force in figure A, which is in upward direction perpendicular to the contacting surface of the table, and it is denoted by F and a little subscript N. And in diagram B, there is thrust force, which is denoted by subscript T, and it is always opposite to the motion of the hot gases. So next is friction. What is friction? Whenever you are pushing or pulling a box, you are experiencing a resistive force, a force that is acting opposite to your applied force, that is acting opposite to the direction of the motion of that object, and it is called friction force. In figure C, there is a little red arrow beneath the box in opposite direction to the push, which is denoting the force of friction. Next is tension. What is tension? So when you extend a weight by a string, then the string is in tension due to the downward weight. So now weight is acting downward, and according to Newton's law, there is a reaction force also, which is in upward direction, and that force is the force of tension that is induced in the string, and it is denoted in figure C. In figure D, there is a tension force in upward direction, and there is a subscript T. So these two forces are also example of contact forces. And next is non-contact forces. Non-contact forces, as obvious by its name, are the forces which acts without being in physical contact. Means that they can act at some distance. So for example, you experience gravitational force that is a non-contact force. What is gravitational force? Let's say you are holding a board marker in your hand, and you raise it up to some height, and then you release it. That board marker comes downward on the surface of earth. So now there is no physical contact between the earth and the board marker when it is at some height. There is air in between them, so there is no physical contact between two bodies, but earth attracts the board marker to its surface. So this is because the gravitational force is non-contact force, means it can influence any object at some distance without coming into physical contact. So next is electrostatic force. Electrostatic force is a force between two charged particles. It can be attractive or it can be repulsive. Keep in your mind that gravitational force is always attractive, but electrostatic force can be repulsive also. So you can perform a little experiment in your home. You can take some piece of papers and a comb, rub in your hairs, and then bring it to near to those piece of papers. You will see attraction between the comb and the pieces of paper. So that is because there is electrostatic force acting between those particles. So electrostatic force is also a non-contact force. It can influence the charged bodies present at some distance. Although electrostatic force strength decreases with the increase in the distance, but it is a non-contact force.